and welcome to day one of graphing our quadratic functions. So we have been factoring and solving and doing all sorts of fun stuff with these quadratic functions, and now we're going to see what they look like on a graph. So we are going to be graphing parabolas. So in order to graph these as parabolas, we need to take our quadratic function that we've been seeing in this form, and we are going to rewrite it in vertex form, which is a times x minus h squared plus k, where hk is the vertex of our parabola. So how do we go from our quadratic function to vertex form? We do that by completing the square, which we are familiar with. So let's jump right into an example. We are going to complete the square using the first two terms in our quadratic. So if I were to rewrite this and want to make this a perfect square trinomial, remember you half the middle term and then square it. So that is going to be negative 2 squared, which is positive 4. And remember, if I add it on one side, I have to add it on the other. But because we're writing the equation in vertex form where y is by itself, I'm going to need to subtract that 4 on both sides to get y by itself. So now I rewrite this perfect square trinomial as a squared binomial. And 7 minus 4 is 3. So here is my equation in vertex form, and my vertex is going to be 2, 3. Now, you might be tempted to say negative 2, 3. However, our form is x minus h. So if we have x minus a number, our x value for our vertex is positive, and if we have x plus a number, our x value for our vertex is going to be negative. So let's take another look-see. At b, again, we're going to start by completing the square. So the first thing I need to do is factor out that negative. So negative x squared minus 2x plus whatever is going to make that a perfect square trinomial. So half the middle term, that is going to be negative 1, and you square it, that gives us positive 1. Now, because we factored out a negative, that means we have to multiply that 1 by the negative to figure out what we're going to put on the other side. So that's actually going to be negative 1 on our other side. So to move it, we have to add it. So that's going to be negative x minus 1 squared minus 6. So our vertex is going to be negative 1, negative 6. Actually, positive 1, excuse me. X minus h, positive 1, negative 6. So when we are going from our quadratic into vertex form, we're going to factor out the a, get our perfect square trinomial, and whatever we're adding inside is going to end up being subtracted outside of our parentheses. So let's practice that again. I want to complete the square here, so I'm going to factor out that 2 first. Now remember, if it does not evenly divide by the coefficient of the next term, we're going to leave it as a fraction. And so whatever I add inside, I'm going to have to subtract outside. So I half the middle term. Half of 3 over 2 is 3 over 4. That squared is going to be 9 over 16. Now, remember, I factored out a 2, so what I'm going to subtract is going to be 9 over 16 times 2. So that's going to be 18 over 16. So rewriting this in vertex form is going to be 2 times x minus 3 over 4 squared. Now, this is a nasty fraction, and if I don't want to do it in my head, I can do it in the calculator. So 7 minus 18 over 16. And I can convert this into a fraction by hitting, oops, focus, the math button, enter, enter. So 47 over 8. So this math button, enter, enter. So 47 over 8. And our vertex is hk. So 3/4, 47 over 8. That is our vertex. So now let's practice graphing. When we are going to be graphing our parabola, I'm going to rewrite our vertex form up here just so that we have it handy on the back side. First, we're going to plot and find our vertex. Remember, your vertex is hk. So we're going to rewrite it in vertex form, find h and k. Then we're going to draw our axis of symmetry, and this is going to be the vertical line along this h value. So whatever the x coordinate is of our vertex, that's where our axis of symmetry is, that vertical line. Then we are going to plot the y-intercepts. Remember, the y-intercept is when x is equal to 0. and the symmetric point, and we're going to use the axis of symmetry to find that. Then we find our x-intercepts, and that is when y is equal to 0. And then we just connect the dots with a smooth curve. So let's start with step 1 here. We first need to rewrite this in vertex form, so we're going to complete the square. Start by factoring out that 2. And whatever I add inside is going to be subtracted on the outside. So half the middle term, that's 2, square it, that's 4. Then because I factored out a 2, I have to multiply that back out, so I'm going to subtract 8. So rewriting this in vertex form, I'm going to write this as a squared binomial. 7 minus 8 is -1. So my vertex is going to be -2, -1. Now remember, it's x minus h. So because I have this plus 2 here, that means that it was x minus -2, which became positive. So my vertex, I'm going to go ahead and plot it, -2, -1. Then step 2 is to find our axis of symmetry, and that's where x is equal to our h value, -2. So I'm going to draw that in green here so that it's easier to see. So 1, 2. So x equals -2. There's our axis of symmetry. Now we're on to step 3, which is finding our y-intercept. So we're going to plug in 0 to our equation for x. So f of x is equal to 2 times 0 plus 2 squared minus 1. So it's going to be 2 times 2 squared minus 1. 2 squared is 4, times 2 is 8. So 8 minus 1 is 7. So my y-intercept is 1, 2, 3, 4, 5, 6, 7. Now this is where we find the symmetric point using our axis of symmetry. So this y-intercept is 2 away on the right side from the axis of symmetry. So the symmetric point is going to be 2 away on the left side. So that's how you find the symmetric point using your axis of symmetry. Now we're ready for step 4, which is finding our x-intercepts. So that's when y is equal to 0. So we are going to set our equation equal to 0 and solve. So the first step is to add that 1, and we're going to divide by 2. Then we square root both sides. This should look pretty familiar. We were doing this, and remember that's going to be plus or minus the square root of 1/2. So the last step is to subtract that 2, so -2 plus or minus square root of 1/2. Now this is going to be an ugly, nasty number, so I'm going to put it into my calculator to get a decimal, and we're just going to estimate that. So let's just do -2 plus square root of 1/2 first, and that's approximately -1.3. So I am just going to eyeball that, approximately -1.3. And now I can use my axis of symmetry to draw the other point. It's going to be equidistant on the other side of my axis. And now I'm ready to connect the dots. There we go. All right, next one. Again, step 1, we need to rewrite this in vertex form and find the vertex. So first thing I'm going to do is factor out that 2, and we are going to complete the square. And whatever we're adding inside the parentheses, we have to subtract outside. So half of that middle term is going to be 3 over 2. 3 over 2 squared is 9 over 4. Then I have to multiply that by 2, so that's going to be 18 over 4 that's getting subtracted. So 2 times x plus 3 over 2 squared. Then in my calculator, 2 minus 18 over 4. Math, enter, enter. And that fraction is -5 over 2. So minus 5 over 2. So our vertex is -3 over 2, -5 over 2. So what I'm going to do, since these are kind of tiny grids, is I'm going to scale this graph and let every grid mark be a half. So that will be -1, -2, -3, and so on. So -3 halves, -5 halves. There's our vertex. Now step 2, we find our axis of symmetry, and that's where x is equal to h. So that's going to be -3 over 2. So there's our axis of symmetry. Now we're on to step 3, which is finding our y-intercepts, where x is equal to 0. So we plug in 0 to our equation. So that's going to be 2 times 3 over 2 squared is 9 over 4. So 18 over 4 minus 5 over 2, and we can do that in our calculator. 18 over 4 minus 5 over 2, and that is 2. So our y-intercept is going to be 2. And then we use our axis of symmetry to do the symmetric point. And this y-intercept is 3 away from the axis of symmetry on the right. So we're going to find the point that's 3 away on the left. And now we're ready for step 4, which is finding our x-intercepts. So we're going to set our equation equal to 0. And again, we're going to get 2 values. So we're going to add the 5 over 2, then divide by 2. And then we can go ahead and square root both sides. So x plus 3 over 2 is going to be plus or minus square root of 5 over 2. So then the last step is to subtract the 3 over 2. And we can actually rewrite this as one fraction if you'd like, since they have a common denominator. So again, I can just type one of these into the calculator. And then we can use our axis of symmetry to find the other one. So negative 3 plus the square root of 5 divided by 2. That's about negative 0.4. So about there. And then I'm going to use my axis of symmetry to plot the other one. And then I can connect the dots. And there is my second parabola. So we are going to be continuing this on our next class period because this is kind of a tricky topic. I don't expect you to be an expert on it right away, but that concludes the day 1 notes.